Welcome guys to this new tutorial video. This is the Mission Gizmo channel. In today's video, we'll be looking at an S7 communication protocol, which is put and get. Put and get is a Siemens S7 protocol. It's proprietary to Siemens, so you can communicate between two S7 PLCs. You can transfer data between two S7 PLCs. So in this video, you're going to learn how to transfer data between two Siemens PLCs, S7 PLCs, using put and get. For this video, I'm going to use virtual PLCs to simulate this video. Okay, so I've created two PLCs in this tutorial, in this project, PLC1 and PLC2. Um, and I'm going to be using PLC Sim Advanced. So Siemens PLC Sim Advanced. So PLC Sim Advanced is used to simulate more advanced um, um, protocols than the ordinary PLC Sim. So the first thing, I'm going to give IP address to my two PLCs. So for this PLC, I going to give it a the IP address will be 192.168.0.10. Y for the second PLC is going to be 0.15. So already my system is on 0.20. So then the next thing we want to do is we have to activate put and get protocol in both PLCs. So you click on PLC, scroll down to protection and security, and then you scroll down, you're going to see permit access with put and get communication from remote partner. So we're going to permit that in both PLCs. Okay, and then we'll head up to PLC Sim Advanced and create a new virtual PLC. So the first one is going to be PLC1. I'll call it first PLC. Oh no, then IP is 192.168.0.10. Subnet is 255.255.255.0. Then I'm just going to start. I'm going to start instance. Instance has been started. And then I'm going to do the second PLC. And this is 0.15. And I'm going to start. So then I'm going to just download the two PLCs into the simulator. Start with the first one. So PNIA. So now we're using PLC, Siemens PLC Sim Virtual Ethernet Adapter. From search. Then load. Oh, error. Let's download again. Let's ensure that they are both on the same subnet. Then we download again. Okay, good. I'm still getting error. Okay, so one of the things you want to check is that under properties, you protection of the properties of the project, you support simulation during block compilation. You always check this. It's important. Okay. So we'll download PLC2 and then we'll put the PLCs in run mode. Okay, so they're both in run mode. So I'll head over to PLC1 and I'm gonna create a data block where I'm gonna store my data area. Then I'm gonna create a um just an array for my data. Call it data, and the data type is going to be an array of 1 to 50 of real. Now also I want to remove optimized access from optimized block access, so I could use a pointer to direct to the PLCs. So next thing I want to do is okay, PLC1 will be my puts, PLC for putting and also for getting. So I'll head over to the main block. I'm just going to program on OB1. Then so to get the put function block, you come to communication, S7 communication, then put. Okay, it's going to create a DB for you, an instance DB where it's going to hold the put data. Yeah. Another thing I want to do is that put and get works on a rising edge. So I want to activate a clock bit. So system and clock memory. Here you're gonna see system bytes and clock bytes. So clock bytes are like the CPU's internal clock memories. So I will just compile this and download. So with this, okay. I'm not done programming yet, so I'll finish programming then I'll just download. So with this, I want it to run on a rising edge. So M0.5 is clock 1S, which is 1 second. So 1S is 1 second. So this block is going to request for data every 1 second. Then the next thing you want to do is I always like to create an internal block parameters for done bits, error, status, which is word. Yeah, so I'll tag this done, error, and status. So another thing is I will want to also move my error bit, my status bit. So once I have error, PLC will be able to tell me the current error. So I want to move status into MW 150. So anytime I check MW 150, I'm going to see the current status of my put block. So another thing we want to check is how to configure this block. Now Siemens has made put and get easy in 1200 and 1500 PLCs. So for this this blue column here, you can click on it. So this is going to open the configuration for configuring put and gets. So now for these, you have unspecified and you have PLC2s. Now, because I'm in the same project, my two PLCs are in the same project, I could just pick this. But if for example, two PLCs are different projects, maybe different OEMs they did installation, I'm gonna speak on unspecified. So unspecified is when they are in two different tier projects or semantic manager projects. So I can use unspecified where I'll just impute only the IP address. But since they're in the same project, I could just choose PLC2 and then everything is just gonna pop up, the IPs and all. And yes, also Siemens also creates an S7 connection name and ID for it for you. And then also this is an active connection. So now that same number comes there. So you don't need to impute this. If you configure uh do the configuration properly, it's going to automatically create a connection ID for you and also a connection name. So another thing I want to do is address. ADDR1 is like if you check, it says remote. So remote is the data block address of the other PLC. Why this is local, which is the data where the data is contained in this PLC. And that's why we created a DB here, which is DB of arrays 1 to 50. So another thing you want to so before that I want to read from data 1 to data 41. So the syntax is this p hash db1 dot dbx. I'm starting from 0, so 0.0, which is the first byte, which is the first element in the data block. P hash db1 dot dbx 0.0 bytes. And what's that again? 41. Yeah, it's byte 1164. So with this, oh, this is supposed to be in remote, in local. So for remotes, we'll have to create a data block in our remote PLC also. I'll give this thing db3 also, and then I'm also going to create a data array of 1 to 50 of real. Okay, I'm going to remove optimize block access and then compile. So this is db3. So back to PLC1, I'm going to send the data to ph db3 dot dbx 0.0 bytes 164. So now I'm going to be sending from db1 on PLC1 to db3 in PLC2, which is the second PLC2. So with this, we've configured the puts. So another thing we need to know is that puts and get is unidirectional. It's not bidirectional. So that means you only need to configure. You can only transfer data one way. It's one stream. You don't need to configure it in one PLC. So if you are configuring put in this PLC, that's all. If you're configuring get in this PLC, that's all. You don't need to configure both ends, unlike other S7 communication, which we'll look at in subsequent tutorials. But for put and get, you just need to configure in one PLC only. So with these, we can compile and download. So we're going to download. and then I can go online to check the status of my block. Oh, I have an error. So what will happen is I'll just download the hardware. Okay, so I monitor again. Still an error. So I'm going to download the software all. Also in PLC2, I'm going to download. Okay, check my PLCs so they're running, and then I'll monitor again. Still an error saying 16 hash 001. Next thing to do is to check the diagnostics connections. Not available, so I want to download again. Monitor again. Oh, still red. So I want to download PLC2. Oh, good. So now it's green. So it's green. So back to my block. Monitor. So the error is false. So I'll attempt to write from PLC1 since this is put. I'll attempt to write some values and monitor it and see if it comes in PLC2. So I'm going to edit this, put 12.35. That's random values. This 6.223, 8.995. This um that's 11.025. This. So I'll check. So these values I'm putting here, I'll check if it's appearing in PLC2 data block. Voila. So it's appearing. So we've successfully written data from PLC1 to PLC2. As you can see, this is PLC1. So I can do this for you. This is PLC1 values, and this is PLC2. Yeah, this PLC1 values, yeah, and this PLC2 values. So you can see that our block is working, it's transferring. So another thing we want to know is that for S7 1200, you can only send 160 bytes at once. So for put and get S7 communication in 1200 PLC, Siemens 1200 PLC, you can only send 160 bytes. While for 1500 PLC, you can send 880 bytes. So for 1500, you can send 880 bytes. So that's for 1500. So Thank you very much, guys, for watching this video. So always don't forget to like, share, and subscribe.